Yes, this is Democracy Now!, broadcasting live from COP21, where representatives from nearly 200 nations are in the final stretches of negotiations aimed at reaching an accord to avoid the most catastrophic impacts of climate change. Our next guest has spent the last 2 decades tracking global warming from one of the front lines of climate change, Greenland's ice sheets. From 2008 to 2012, Jason Box was the lead author of the Greenland section of NOAA's annual climate change report. That's the National Oceanic and Atmospheric Administration's annual climate change report. In 2012, he was one of the first scientists to warn there would be surface melting across the entirety of Greenland within a decade, a prediction that drew scorn from many in the scientific community until the melting began only a few months later. Jason Box has also participated in protests against climate change, including the 2011 mass protest at the White House. His most recent piece for the New Yorker magazine, co-authored with Naomi Klein, is headlined, "Why a Climate Deal is the Best Hope for Peace." Earlier this year, Esquire ran a profile of Jason Box, headlined, "When the End of Human Civilization is Your Day Job." Jason Box, welcome to Democracy Now!
Thanks.
So, talk about Greenland and what's happening and why people should care around the world.
Well, Greenland ice and ice around the world are really good indicators of climate change. That and Arctic climate change is proceeding at about twice the rate of the lower latitudes. The impacts are important globally, even though this is a remote place. We not only sea level rise, which NASA confirmed 1 meter of sea level rise is locked in by the end of the century, and we can't rule out more than that. We don't yet have the models that have specific processes that we know that are happening in the field from our observations. They're not encoded in the climate models, so we have to look into the past. And what we see is the last time that atmospheric CO2 was at 400 parts per million, global sea level was at least 6 meters higher. So we urgently need to reduce emissions, but also somehow draw down atmospheric carbon. And one great natural technology to do that is in the form of trees and grasses, and to restore soil carbon stores. That's a known kind of technology, natural technology that we need to urgently pursue now.
So how did you end up first going to Greenland? And explain what it looks like as the ice sheet melts.
We selected Greenland as a climate laboratory because we can conduct experiments and monitor over a large scale and compare our ground measurements with satellite and climate models. So we're running a network of measurements, and it's now going beyond 20 years. And so while spending time in Greenland, we see numerous physical things happening that are not yet in the models. For example, the snow line on the ice sheet is rising, and below the snow line is a dark, bare ice area. That absorbs a lot more sunlight during these 24-hour sunlit days. That's one multiplying factor. Another is increasing rainfall on the Greenland ice sheet. That darkens the surface. Warming is bringing more rainfall, more lubrication to the flow of the ice sheet. We observe lakes forming higher on the inland ice. We observe a darkening of the bare ice area that's due to microbial blooms. Then wildfire increasing in the Arctic is also something that we're tracking through a crowdfunded activity called the Dark Snow Project at darksnow.org. And so there's numerous multiplying factors that we're finding that just aren't in the climate models yet.
What is Jakobshavn?
The Jakobshavn Glacier is the world's fastest continuously flowing glacier. It used to have an ice shelf in front of it when I started working in Greenland. And that area, that ice shelf, more than 1.5 times the size of Manhattan Island, that ice shelf disintegrated. We didn't recognize the Jakobshavn Glacier in the year 2003. The landscape had transformed. And so this world's fastest glacier has more than doubled in speed. So it's decanting the Greenland ice sheet And it's not alone. There are dozens of other marine terminating glaciers like this. Consequently, the Greenland sea level contribution has more than doubled in the last 20 years. And so if we start thinking in doubling times, Greenland's contribution is on the order of 12 to 14-year doubling times. That delivers globally from other land ice masses, including Antarctica, the bigger ice sheet, more than a meter of sea level rise by the end of this century.
So what has to be done, and do you feel what's happening at COP21, the 1.5 degrees Celsius or 2.7 degree Fahrenheit target, albeit voluntary target, is important?
Well, it's nice to have those aspirations, and it raises hope, that's for sure. But the numbers that the different countries brought, the US and Canada, for example, they're not consistent with these 1.5 degree or even 2 degree targets. So this is like goodwill rhetoric. It makes us feel good, but without a binding mechanism with teeth, a legally binding mechanism, they can say whatever numbers they want and make us feel good. But again, the emissions reduction scenarios that are on the table from the United States and Canada fall far short of hitting that or going through that temperature target. So really what we need to be talking about is that atmospheric carbon level that we can tolerate, and unfortunately it's too high now. So the missing conversation is also about atmospheric drawdown of carbon. And that's why I bring up trees and grasslands and restoring growing parts of our planet. We've lost 1/3 of arable land on our planet in the last 50 years. We need to start reversing that, and we can bring humidification back to the Mediterranean. The Roman Empire began deforesting the Mediterranean long ago, and that desertification trend is behind the drought, and we can actually begin reversing that, and it actually, besides bringing moisture back to some of these places and sequestering carbon, it also gives people hope, and it can be a gesture of peace that we can offer around the world.
Let me ask you, Jason Box, as a leading glaciologist, scientist, about ExxonMobil and about this expose done by Los Angeles Times and Inside Climate News that shows these documents that Exxon knew in the 1970s, working with top scientists about climate change. Last weekend, you participated in a very novel kind of mock trial. The prosecutors were author Naomi Klein and 350.org co-founder Bill McKibben. And you talked about the significance of these new documents that have come out. Explain why we know what Exxon knew, but then covered up.
I mean, my participation was as an expert witness, and I read the early scientific documents as part of this Inside Climate News revelations, this expose. It's the clarity of the science that Exxon was producing in the early 80s is crystal clear. The technologies they were using, that climate science was state of the art. It still rivals some of the science we have today. And for Exxon to then take a public position and a position with their shareholders that was not consistent with their very carefully worked out science.
Why were they doing this science? Did they say, we want to know about the state of climate change?
The reporting is clear that their leaders in the 70s took this risk factor seriously because it risks their business model. And so they wanted to know using their own people, and they were very well funded, and the documents are very well written, climate science. They then connected that with their product could not be sold anymore. They could not convince shareholders that their product was viable, but they went ahead and lied to the public, and they lied to their shareholders.
How?
By flatly denying it and by using uncertainty. They brought the rhetoric of uncertainty into their messaging from their CEO to shareholders and to the public.
What happened to the scientific team that they hired to research this?
They defunded their science. That there was an economic crisis at the time that they justified some of that defunding. But then they take a public position that is counter to their own science, is in effect lying in public on issues just to keep their product sellable, and that cost us 20 years. And if they had come straight and recognized themselves as an energy company, they could have made that transition with us to cleaner energy and remained a viable company. Now they're a rogue company.
The results of that cover-up?
Well, it's we made this mock trial, and what clearly needs to happen is that true justice comes to this issue. Climate change it's a justice issue. It's an environmental justice issue, and this couldn't be a more clear case.
Finally, what keeps your spirits up when you see what is happening? The Esquire subtitle, among many climate scientists, gloom has set in. Things are worse than we think, but they can't really talk about it. Do you see self-censorship among scientists, and what gives you hope here?
Well, I'm actually not wanting to be a messenger of doom, because I see a lot of hope in the explosive growth in renewables. And the fact that renewables are cheaper than nuclear, they're cheaper than fossil fuels in many existing markets around the world. And that growth is going to surprise a lot of people, how clean energy just takes over because it's better economically. I see that coming. That gives me hope. I sense actually in this meeting how broad this movement is becoming, the awareness of this problem, and it's broadening. So it's gaining momentum, and I think that momentum will continue through Paris. There's a lot of hard work to do. It's not going to be easy, but we're doing this for our kids and for nature.
Jason Box, I want to thank you for being with us. Professor of glaciology at the Geological Survey of Denmark and Greenland. He's been studying the Greenland ice sheet since 1994.